in this video we'll go over free response question from 2013, number 5, on area and volume. Before we get started, go ahead and download the question and try it out. Note that no calculator is allowed for this problem. Okay, as we look at part A, I'm going to go to the graph for a moment. You're given this graph and you're told that the region R is between two functions, f and g. Now your first step really is to identify both the endpoints and which function is which. So you'll notice in this problem that 0 and 2 are the endpoints. Those are clearly labeled on the graph, and because you don't have a calculator, you need to just take that at their word and move on from there. The second thing is you want to identify which function is which. So notice that this bottom function is more curved. That looks like an x squared function to me, while this other one looks more like a cosine. Now if you're not sure for any reason, go ahead and plug in some points by hand and see which one is which. Okay, getting back to our problem. In part A, we're asked to find the area of the region. So what we want to do here is, again, identify those endpoints first, which are 0 and 2, because those are going to go on our integral here. And then identify the top and the bottom function, because to find the area, we want to take the function on top minus the function on bottom. So here, the top function is that cosine function, 4 cosine pi x over 4, minus our quadratic function, 2x squared minus 6x plus 4. You absolutely need to write out that statement, whether it's a calculator or non-calculator question. You always want to write out the integral correctly to show that you understand what you're finding. Here, though, you also have to solve this by hand, and this is a pretty hefty solving by hand question. So in the second line, we're going to integrate. So here the 4 stays, cosine becomes sine, but we have this pi x over 4. So to divide by that, we multiply by 4 over pi, the reciprocal. Over here, it's a little more standard. 2x squared becomes 2x cubed over 3, 6x becomes minus 3x squared, and 4 becomes 4x. Next, we're going to evaluate that from 0 to 2. The only easy part here you'll notice is when we plug in 0, everything, all the terms become 0. So I just have a minus 0 on the end here. Plugging in 2 is a little more work. So we're going to plug in 2 for all the x's in the previous equation. So I've done that on this line here. You'll notice one common mistake I see is where sine 2 pi over 4. That's not the same as 2 times sine pi over 4. So you want to plug in the number first, then evaluate this new term. So 2 pi over 4 is the same as pi over 2. So sine of pi over 2 is 1. Down here I've multiplied 4 times 4 into 16 over pi. Here we've combined the 2's. We have 16 thirds. 3 times 2 squared or 4 becomes negative 12 here, and 4 times 2 becomes plus 8. Now this is a messy looking integral. As you combine it, you have 16 over pi minus 4 thirds. You have to stop there because you don't want to simplify pi any further, or anytime you have a symbol that represents an irrational number. So like pi or e, you don't want to simplify them any further. You just leave as is. Let's take a look at the scoring. This was worth 4 points. Pretty impressive for an area question. 1 point for writing the integrand, so what's inside the integral correctly, as well as the 0 and 2. 2 points for finding the antiderivative. I think that's fair given the complexity of the antiderivative. And then 1 point for getting the correct answer. I suspect some people did this problem correctly and then thought they made a mistake because the answer looks so messy. It's not a nice clean number like 10 or 70. You have this expression left over. Now that's going to be the case sometimes on non-calculator questions, so don't let it bother you if you're pretty confident that you did it correctly. The question graders are looking for multiple things here. First, that you set up the integral. Then that you can find the antiderivative of sine, use a u substitution or do it in your head, as well as kind of basic antiderivatives, and then that you can plug in and evaluate all of those terms correctly. On part B, we're asked to find the volume of the solid if we rotate it around the line y equals 4. So a couple things you want to start with. First, I find it helpful to draw in the line. So here I've drawn in the line y equals 4 on our graph. And then in general, what we're doing is pi times the integral from a to b of big R squared minus little r squared. Notice I've made a little error on the slide here, so they should both have pi's in front of them as our regular equation. Second part is identifying the big R and little r in your equation. And a lot of students have trouble with this because it's more challenging than we think sometimes. So big R should always represent the distance from your line of rotation to the farthest part of your region. So you'll notice here we've got big R is that larger arrow from the bottom of the region to the line, and little r should represent the distance from your line of rotation to the closest point on your region, or the closest part of your region. Because little r is really the in-between space that we're deleting, okay, that we're subtracting. So to get my equation in the second line here, 4 minus f of x squared minus 4 minus g of x squared, I'm using 4 represents this whole line. F of x represents the part from the x-axis to the function. So what's left over is 4 minus f of x gives me big R. And similarly, 4 minus g of x, the distance from the x-axis to this function, gives me little r. So I put those both in there, and in this equation they asked us not to evaluate, so that's your answer, or you can also plug in what f and g actually are. If we look at the scoring here, there was 3 points, 2 for the integrand, because again that's probably the challenging part, and then 1 point for the limits and the constant. So you wanted both the 0 to 2 as the limits on the integral and pi out in front of the integral to get that third point. For the equation, there was probably a little bit of partial credit, but not much, because generally if you understand this idea, you probably got 4 minus f of x and squared it, and similarly over here. So probably only for extremely minor mistakes would they give partial credit. Okay, the last part, again, a commonly asked question, asked us for the base of the solid. So the region R is the base of a solid, and we're building up a solid by using square cross sections. Now, as we look at the problem, it tells us several pieces of information we need to know. So I'm going to go back to the graph for a minute here. So notice we're looking at our region R and we're building up square cross sections. We need to know which way the squares go. So it tells us they're perpendicular to the x-axis. So that means I'm going to have an up and down square. So the side of my square is going to lie from here to here, okay, versus a horizontal laying square. That's very important because the equation would be totally different. So going back to part C here, I'm still going from 0 to 2, so my limits on the integral haven't changed. And then in here, I want the equation side squared, because I'm talking about the area of a square inside here. So the area of a square is just side times side. So that just is g minus f, because the side of my square is lying on the region, and we know the region is g minus f. So I just take that and I square it to get the area of a square. So here I have the full answer written out, 4 cosine pi x over 4 minus 2x squared minus 6x plus 4, all of that squared gives me my side squared in here for the answer. Now one thing they're looking for on the scoring, they're looking for your integrand, but they're also looking at your limits and constant. And that's because a lot of mistakes are made here because students throw in an extra pi. Because we're so used to writing pi r squared for volume, sometimes you forget that that's only because when you do a rotation, your cross-section is a circle. Okay, here if we're doing a different cross-section like a square, there's no pi because pi r squared is the equation for the area of a circle, not a square.